Hello class, so in this problem here we're calculating the acceleration of the block if the coefficient of friction was 0.25 and the mass is 2.0 kilogram. So the first thing we want to do here is we want to draw the forces that are acting on this box. So we have the normal force is always 90 degrees or perpendicular to the surface. We have well, let's do that last. We have the force of friction would be moving opposite the motion of the box, assuming here that's going to slide down. We don't have an applied force. We have the force of gravity is straight down, that's Fg. However, this is an incline force. That force is going to have to be broken into the perpendicular and the parallel components. The perpendicular component is going to be perpendicular to the surface, obviously in the opposite direction, so that's going to be this component of the force. The parallel one is going to be parallel to the surface of the incline, which is in this direction right here. Okay, or you can redraw it right here. Okay, so that's going to be your Fg parallel. Okay, you can write it again, either direction doesn't really matter. And Fg perpendicular is going to be the one that is going to be, in this case, equaling F normal force. So, in the y direction, we can write the formula for F net. So F net y. So again, if you want to redraw this free body diagram separately, away from the box, away from the incline, we have the normal force, we have the force of friction. Well, in this case here, let's do the force of friction on the other side. So it would be negative. Let's just keep it as is, I guess. Force of friction up to the right, on to the left we have the Fg parallel, and down we have Fg perpendicular. Okay, so F net in the y direction, that's going to equal F normal, normal force, minus Fg perpendicular. So, and that equals 0. So Fg perpendicular, so that would lead us to find the Fn, or normal force. Again, if you don't know where you're going, just find something. In this case, I'm finding normal force. So the normal force equals Fg, which is 2.0 kilograms multiplied by the acceleration of gravity, 9.8 meters per second squared. And this is the component that is, so remember, this angle here, 20, is the same as this angle. You can see me in class to explain where that's come from again, but it's not necessary. But I'm not going to ask the question, but it is the same angle. Anyway, this is the adjacent side to the angle 20 in this triangle right here, which makes this cosine. We need to use the cosine of the angle, cosine 20. You put that in the calculator and you're going to end up with 18 rounded to the nearest to the two significant figures here, 18 newtons. That's your normal force. So that would lead us to find out what the force of friction is right away. So in this case, force of friction, again, in the drawing here, we decided it is positive. Force of friction is 0.25 multiplied by 18 newtons, the normal force, and that is 4.5 newtons. Again, we're looking for the acceleration, so we're not there yet. So let's see what we can find. The FG parallel, we probably, well, that doesn't help us so much at the moment, but let's see what else we can use. Acceleration, we know it's an F-net thing because it is where acceleration comes from of the object. The net force is what decides what the acceleration is. So F, we find the F-net Y, which was 0. Let's look at the F-net X, or along the plane, the incline in this case. So that would be the mass of the object, the block, times the acceleration of it, which equals, let's look at the forces. Well, we have the force of friction is already positive here again, and negative is going to be the force of gravity, the parallel version of that. So we already have the force of friction, 4.5 newtons. So we have 4.5 newtons minus force of gravity parallel would be 2.0 kilograms times 9.8 meters per second squared multiplied by sine of the angle 20 in this case. Okay, again, it's sine because we're looking here at the opposite side of this triangle. The opposite is the parallel, the opposite is the sine, of course. So let's say O in so. Okay, we put these numbers in the calculator. We will end up with mass times acceleration. So if we're looking for the acceleration here, just to make life easier, we'll divide everything in here by the mass. So we have 6.7 newtons minus 4.5 newtons divided by the mass, which is 2.0 kilograms, and that would yield an answer of 1.1 sorry, it's backward here, we got the numbers mixed up. We have 4.5 minus 6.7, and these are newtons, and we will end up with 2.2, negative 2.2 newtons divided by 2, or negative 1.1, meaning it's moving in this direction to the left, right? And that's surprising. Or you can say acceleration is 1.1 meters per second squared down the incline. That's it.